In 2013, astronomers made a discovery that should have been impossible. They found a star, HD 140283, that appeared to be 14.5 billion years old. There's just one problem. The universe itself is only 13.8 billion years old. This star shouldn't exist. But there it is, burning bright in our telescopes, 190 light-years away, mocking everything we thought we knew about cosmic history. How can something be older than existence itself? And what does this impossible star reveal about the deepest mysteries of our universe? Our story begins not with a single moment of discovery, but with decades of astronomical detective work that slowly revealed an impossible truth. Meet HD 140283. To most people, it's just another point of light in the constellation Libra. But to astronomers, it's become known as the Methuselah star, and it's been haunting them for over a century. The first clue that something was strange came decades ago. Astronomers noticed this star was moving. Fast. Really fast. HD 140283 races through our galaxy at 800,000 miles per hour, fast enough to circle Earth in 3 minutes. But speed wasn't the only weird thing about this star. When astronomers analyzed its light spectrum, they found something disturbing. HD 140283 contains almost no heavy elements. No iron, no carbon, no oxygen, just hydrogen and helium, with trace amounts of lithium. To understand why this is terrifying, you need to know how stars work. Stars are cosmic furnaces. They fuse hydrogen into helium, helium into carbon, carbon into oxygen, and so on up the periodic table. When massive stars die, they explode as supernovae, scattering these heavy elements across the galaxy. These elements then get incorporated into new stars. It's a cosmic recycling program that's been running for billions of years. Every generation of stars is more metal-rich than the last. The iron in your blood was forged in the heart of a dying star. The oxygen you're breathing right now was created by stellar fusion. But HD 140283 has almost none of these elements. It's what astronomers call metal poor, which means it formed when the universe was young, before generations of stars had lived and died to enrich the cosmos with heavy elements. So how young are we talking? Using the star's composition as a cosmic clock, astronomers calculated that HD 140283 formed when the universe was less than 1 billion years old. That would make it one of the oldest objects we've ever found. But then came the precise measurements. The Hubble Space Telescope spent years studying this star, measuring its distance, brightness, and temperature with unprecedented accuracy. And when astronomers plugged those numbers into their stellar evolution models, they got a result that broke physics. 14.5 billion years old, plus or minus 800 million years. Let me repeat that. This star appeared to be older than the universe itself. The Big Bang happened 13.8 billion years ago. Everything, matter, energy, space, time, began at that moment. Nothing can be older than the Big Bang because there was no before the Big Bang. Yet here was HD 140283, burning in space like a cosmic middle finger to our understanding of reality. The discovery sent shockwaves through the astronomical community. How do you explain a star that predates existence? Some scientists wondered if our measurements were wrong. Maybe the Hubble data contained errors. Maybe our stellar evolution models were flawed. Maybe we'd calculated the age of the universe incorrectly. But as more precise measurements came in, the problem only got worse. The star's age remained stubbornly ancient, while our confidence in the universe's age grew stronger. Others proposed more exotic explanations. What if HD 140283 wasn't formed in our universe at all? What if it came from somewhere else? A previous universe that collapsed before our Big Bang? What if the multiverse theory was real, and this star had somehow crossed over from another reality? These ideas sound like science fiction, but desperate times call for desperate measures. When you find something that shouldn't exist, you start questioning everything. But before we dive into parallel universes and cosmic refugees, let's take a step back and understand what we're really dealing with. HD 140283 isn't just any old star. It's a member of an exclusive club, the Population 2 stars. These are the universe's senior citizens, formed when the cosmos was young and pristine. To understand why these stars are so important, we need to go back to the beginning, the very beginning. In the first few minutes after the Big Bang, the universe was a hot, dense soup of protons and neutrons. As it cooled, these particles combined to form the first atomic nuclei, mostly hydrogen, some helium, and tiny traces of lithium. That's it. For the first few 100 million years, the universe contained only these three elements. No carbon, no oxygen, no iron, no planets, no life. Just vast clouds of pristine gas drifting through the cosmic dark. The first stars formed from this primordial material. They were massive, bright, and short-lived. These Population 3 stars burned through their nuclear fuel quickly and died in spectacular supernova explosions, seeding space with the first heavy elements. The second generation of stars, Population 2, stars like HD 1402883, formed from gas that had been slightly enriched by these early supernovae. They contained trace amounts of heavy elements, but were still essentially made of Big Bang material. Our Sun is a Population 1 star, formed much later from gas that had been enriched by multiple generations of stellar death and rebirth. That's why it's rich in heavy elements, and why planets like Earth could form around it. So when we look at HD 1402883, we're seeing a fossil from the universe's youth. It's been burning steadily for over 14 billion years, a nuclear campfire that has witnessed the entire history of the cosmos. But here's where things get really strange. HD 1402883 isn't just old, it's incredibly well preserved. Most stars this ancient should have evolved into red giants or white dwarfs by now. They should have exhausted their hydrogen fuel and begun fusing heavier elements, puffing up into bloated monsters before collapsing into dense stellar corpses. Yet HD 1402883 is still on the main sequence, still fusing hydrogen in its core like a star a fraction of its age. It's like finding a person who looks 25 but claims to be 200 years old. How is this possible? The answer lies in the star's unusual composition and mass. HD 1402883 is what astronomers call a subdwarf, smaller and less massive than our Sun. Lower mass means lower core temperature, which means slower nuclear burning. It's been sipping its hydrogen fuel like a fine wine, making it last for eons. But even accounting for its leisurely fuel consumption, the star should have evolved by now. The fact that it hasn't suggests something fundamental about our understanding of stellar physics might be wrong. Or maybe our understanding of time itself is flawed. Einstein taught us that time isn't absolute. It flows differently depending on your speed and the strength of nearby gravitational fields. Could HD 1402883 have experienced time differently than the rest of the universe? The star is moving fast, really fast. At 800,000 miles per hour, it's one of the speediest stars in our galactic neighborhood. According to special relativity, high speeds cause time dilation. From HD 1402883's perspective, less time might have passed than we calculate. But the effect would be tiny, nowhere near enough to resolve the age paradox. You'd need to be traveling at a significant fraction of light speed to see major time dilation, and HD 1402883 is nowhere close to that fast. What about gravitational time dilation? Strong gravitational fields also slow down time. Could HD 1402883 have spent part of its life near a black hole or some other massive object? Again, the numbers don't add up. There's no evidence the star has ever been in an extreme gravitational environment. So we're left with a mystery that challenges our most fundamental assumptions about the universe. But wait, what if the mystery is solving itself? In recent years, more precise measurements have begun to chip away at HD 1402883's impossible age. Better distance measurements, improved stellar models, and updated nuclear physics have gradually reduced the star's calculated age. The latest estimates put HD 1402883 at around 13.7 billion years old. Still ancient, but now technically younger than the universe. The margin of error in both measurements means the age paradox might be resolved. But this raises another question. Why did we get it wrong for so long?